My talk is about, well, 50 ways to show you data. I'm not sure if you have had the chance to read the abstract, actually. Was it on the line? No. Because in the abstract it says they may not end up at 50. It's more like 15 or something like that. Okay, with that said. A short way of introducing myself. My name is Thomas Hütter, and you can tell by the umlaut I'm from a German-speaking country. I'm a web application developer. I have to struggle with the software formerly known as Navision, which is Dynamics NAV. And I'm playing around with R for about 4 years now. So bear with me, I don't do anything productive with it. It's not my daily job of mingling with R. It's sort of a cyclic project. Yeah, I'm engaged in the SQL Server community. Usually I talk at SQL Server events. You can see some of them there. We do 60-minute talks, so I have to stuff it together to get into the 45 minutes here, so I'll just go on. So, what's the fuss about this R language? That's something I have to explain to my SQL folks. So who has never worked with R around here is absolute newbie? No one? Good. So you know the flow of your data and all that stuff. Who is not using ggplot on a regular basis? 1, 2, 3 hands, okay. Spares me some time. Okay, that's only the agenda. What I have on the schedule for today, so we'll dig right in. This is what I just, during the break, I adjusted this slide because they did me the favor and actually hit the 13,000 just now. During the lunch break, it was 13,001 packages. I had this squiggly line of around 13,000, and I have been looking at it for days, and today it happened. So there are 13,000 packages on the Grand Mirror. I don't have to tell you what that means. It's a vibrant community, and everybody gives back, and you can profit from it and take a look at it. Also, this one is probably not new to you. Who has never seen that one before? Great. I always wanted to speak in front of the R people. This is my first R event, actually, so bear with me just a little. I'm going to be talking about some packages that add on the ggplot package and some other stuff. I don't have a story to tell from A to Z, from beginning to end, so this is some graphics, some visualizations that I had seen somewhere and thought, how do they do this? Even before I went into R. Part of this are from people who came to me and, hey, I like the visualization like that, how can you do it in R? And I said, okay, I'll do a talk sometime and I'll show you. Most of the folks never showed up again, so I'll do it just for you today. Okay, the grammar of graphics also is familiar to most of you. I just give it a simple approach of what's needed. It's first your data, what you want to show. It's the aesthetics, of course, what goes on the X and Y axis, basically. It's the geometry, what should look like. You wanted a bar graph or a line plot or something. And then you got lots and lots of extras, like you can play around with axes and labels and do faceting and change the coordinate systems and so on. Colors, themes, you name it, they got it. This is a list of the graphics I'm going to show you, which is here in my slides. By the way, you get the slides. I'm not sure how it works. You upload it to the SatRday site or something like that.
Yeah, we can share it later.
Okay, and also the script I've got. So with that, I'll change to this application. You should be familiar with that one also, all of you. Thank you. Can you read it in the back? It's okay? All right. So we'll dive right in. We'll load all of the tidyverse because we'll probably need it later. I did it before. Here you go. This is part of it. So I'm going to use some card data, and at this point I'm going to use some from Formula 1 data because I'm no soccer fan. I don't know anything about football, and So no sports. If I do sports, I watch the Formula One. There's a German site that looks like this. It's called Formel1.de, and they got all the results of the Formula One racing series. Okay, so that's the 2016 one. I took that because there's a German guy up on front. It's got lots of distractions around, like menus and buttons and advertising. What we're interested in is just a table that has all the results. Let me quit this. We can do that by the read HTML function and just pull the data that's in the table. It is formatted as an HTML table, otherwise this wouldn't work, right? So, but then we can use those functions, and we have the data right here, which doesn't look very pretty, of course. So we do some pretty fine, some tidying, of course. First we'll need some column names. We'll then can convert it to a table. And by the way, I filtered on the top 9 drivers only because it gets too cluttered otherwise. Okay, some more mangling. And then it looks like this. We've got a nice table. We've got only the 9 top drivers and all the races and points in the columns. And of course, that's not the really tiny version. I gather it, so we have it in long version, and I add some measures to it. And then it looks like this. Where are we? So that's the long version of the whole stuff. I kept the position, I kept the driver. Here's the total score, which we'll see in a moment. There's the column for the race number. That's the points which have been acquired in that race. And I added 2 columns for the accumulated points and the average. And now we're going to do some visualization on this. So usually when I'm at the SQL folks, I can do this and tell them, hey, that's a valid graph, a valid visualization. I call ggplot, it gave me no error, it's valid. So no surprise for you guys. I can do like this. Also, that's a valid graph, of course. This one already has all our data in it. But of course, that's not what we're interested in. That's not how we would like to see it. Also not this one. Okay, so what we want to see is probably something like this. The race results are in the accumulated manner, or we can see the race results in the average points, the scores. And if we want to see the whole picture, we can also have it, of course, like that. And even though I limited myself to 9 drivers, it's a mess. It's totally cluttered. You can't get anything out of it. So what would you do to give that a better look? A thing called faceting. Of course, to you, that's not new. I can facet on the driver's name with almost the same call to ggplot, make it look like this. That's got the same information in it as the previous one, but it's divided into one graph per driver, and still the auxiliary lines, like the white ones here, make it comparable to see, for example, in race 11, Mr. Perez, he got 0 points. Mr. Hülkenberg, I don't know what it is, 2 or 3 or whatever, 2 probably. That was the famous 5th race. Hamilton and Rosberg crashing into each other, kicking each other out of the race, and Toto Wolff biting into the table because no points for the team. Okay? So,
Max Verstappen winning.
Max Verstappen winning? Where? No, I don't believe it. Really? That's an outlier. Okay, yeah, of course. He had his chance and he got to it. Yeah, sure. He's a fast guy, I mean. Okay, Max Verstappen, yeah, sure. I have a fellow speaker, it's Gianluca Sartori from Italy. He works as a DBA for the Scuderia Ferrari. So you may watch him when Verstappen hits one of the Ferrari drivers. He goes furious on Twitter. Kick him out. What a hole. That's bullshit. Okay. So what else have we got? Yeah, we stick to the Formula One just a little bit. Make it look a little bit more like statistics. So yeah, come on. Box plots. You all know box plots? Who doesn't? Nothing new. Okay, so the two left ones, they look absolutely identical. Still, Rosberg won, because he must have done something differently. Where is it? We don't see it in this one. Why not? Well, because, I give you the summary for those two. Because the statistical values are almost identical. The minimum is at 0, the maximum they share at 25. The median is the same. And the only difference we see here is in the mean value, and that's only in the decimal place. Where Hamilton has 18.1 and Rosberg 18.33. So that's the measure that will show you there's a difference in it. If you just take the other ones, it looks almost similar. And you can get that info out of a box plot. I have one alternative where you may be able to spot the difference, the violin plot. If you look at this one, you know why it's called the violin plot. That's a very nice example of it. But if you look at the Rosberg and Hamilton thing, you see down here at the lower end, Hamilton's violin is a bit wider than Rosberg's. That means he has more of the low point results. And at the top, maybe, like here you can see it, that one is wider than that one, which means Rosberg scored more of the top point results. Because in the end, that makes the difference that Rosberg wins and Hamilton doesn't. All right. I have to clean up a bit in between because otherwise my memory gets cluttered. So to make your day perfect, I also use the MPG data set. And I didn't care about rotary engines or V-shaped VW Porsches. Well, okay, you all know the data set, so we're going to play around with it a little bit. First of all, I calculated the mean city mileage for all the cars by make, and that's something where we Europeans have to watch out because the mileage, as the US folks do it, it's the higher the better, more miles per gallon. We do consumption, which is liter per 100 kilometers. That's the lower the better because you use less petrol. That's sometimes irritating. So we got like, I don't know, what is it, a dozen car makes or so. And the average mileage over all the models that are in there. And of course, we want to do a little visualization of it. Oops, what did I do? Hit the wrong button. Sorry. Stop it! Stop. Go away. Where? Mileage. So, primitive way of doing it, you just give it no options, no colors whatsoever. It looks like that. If you look at it, it might be distorting because it tends to have more distortions between the bars. What can you do about it? Giving it some colors doesn't make it much better even then. And if you want to print something like that, you're going to use the half your ink of your printer probably. So what can you do? Maybe like this, lollipop charts. Anybody use those in practice before? A couple of hands even. So I went into a discussion with the SQL guy. He said, "Oh, lollipop charts is nothing." And the other was, "Yeah, lollipop charts, they're cute." And that was a lady, you might, but yeah. Hi. So you can have them several ways. That one was handmade, so to speak, because it has a GM point and a GM segment in here. but you can also have it in one. Someone pulled them together and created the geom lollipop, which looks exactly the same. Okay, so a cute way to show those measures. All right, what have we got? We stay a bit at the MPG data set. What have we here? Okay. That's, we'll call it scatter plot or something like that. We have the displacement, also the volume of the engine, and on the y-axis we have the mileage in the city. So remember, the higher the better. And we even have a third dimension here, the cylinders of the engines, yeah, with the exception of the rotary ones, defining the colors. Okay? So that's one way to show it. If you want to do, I wouldn't call it clustering, but to make it more clear which ones belong together, where are we? You can do something like that, just one more finger snip, I had said, and do encircling of it. So there you see that all the what is it, 4-cylinder models are within this. Well, let's call it a circle. It's a geometrical shape of some kind. It encloses all the points that fall into the 4-cylinder range. Okay, the same for the 5-cylinder, 6 and 8. So you see where they are. There's an older, that was cars of the 2000. There's an older data set. Let me see. That one is the older data set. That's cars of the 74 year. And I tried to find the difference. What I found just really astonishing was if you watch the top of this, it's around 35 miles per gallon. And if you compare that to the 2000 models, it hasn't changed much in like 25 years. So no big improvement on that. That was something I was really wondering about. Is that true? Is it representative? I don't know. Okay, still mileage. That's the complete MPG data set plotted city mileage versus highway mileage. And if I tell you it's got 235 data points in it, can you give it a quick count? No, you don't have to, 'cause that's a lot less than 235 points. Why is that? Anybody has an idea? Pardon? Overlapping, right, because what the folks do is they don't give us exact numbers. They have the mileage in integers. So you see there's an 18, there's an 18, there's an 8. That's probably, one might be 17.8, one might be 18.2 in reality. So they overlap a lot, and of course you don't see that usually in the graphics. So what can you do to make this visible? There's a geometry called geom jitter, for instance. If we take that, I have to pull it out a bit. Yeah, if you remember down here in the previous, that was just 1 point there, and now you have like 5 points or something like that. So you lose some of the precision, of course, but you get a picture. You get a better picture of the distribution of the points. You see where there are more points and where aren't. Those one up there, those stay single points. So that's just 1 point that's plotted there. But you see, like here, that was probably 1 point before, and that's also maybe five data points which are situated there. Or another way of doing this is just changing the diameter. You see again the single points keep the same shape, and then down there when there was like 5 or 6 points, the point in our graph grows accordingly. Okay, overlaps. Yeah, what else? I have some other overlaps for you. Let me just give me them away. So that's the 74 cars data set again, which has less points, and that's the mileage over the displacement. And if we want to know which car it is, because those are not too many points in there, we can do something like that. And you see that the standard tends to plot the label over the point, and there they run into each other, so that's not very, very good to see. How can we help that? There is something, where am I here? That's something called the geom text. I don't know if is it pronounced repel or repel, I'm not sure. Which gives us something like that. So we have none of the labels really plotted over a point. They're either below or above or something a bit out of the way. And even if they would run into each other like here, the dodge keeps away, and instead it has a little line pointing to the point it refers to. Also down here. So it's easier to spot which car belongs to which point, or vice versa. And we have even an addition to that. Come on. Show me. Where's my colors? That didn't do it before. My system has a life of its own, because that was different colors when I tried it yesterday, I think. It was not shades of blue, it was more like blue and yellow and red. Whatever. Yeah, also we got labels which now have a background color, and the background color contains the third dimension I had introduced before, so you can see that the bright blue things are the 8 cylinders, and the almost black are the 4 cylinders, and so on. Right. Ridge lines. Who has heard of ridge lines or has used them before? Okay, you know what they were called before that? Joy plots. Why was it then deprecated?
Joy division.
Yeah, but that one, even further back, it was some Nazi story behind it. Oh. Okay, I'll show you what they're about. No, I don't. Wait a moment. Where am I? That data set. Oh, I cleaned my data set, of course. Silly me. I have to do it again. Sorry about that. I hope I don't need the second. There you go. There you go. So, those are the ridge lines. They have the visual effect as if they were one behind each other. So it's like, I don't know, I don't like them very much. But that was one example where someone came up to me, hey, can I do joy plots? It was called joy plots then. And I said, yeah, okay. Yeah. Since then, I have them in this demonstration. But yeah. Okay. Considering we don't have too much time, I'll just pass by. Yeah, one thing, tree map is something that I thought was something completely different. What I thought was a tree map is actually a dendrogram. You fell for that trap, did you? Yeah, me too. So, I'm not alone. I have some data, what is it? I have the cell phone data, cell phone subscriptions per country. Oh, that's the big one. Okay, I'm going to cut it down to Europe to make it fast. and that's the tree plot of it. There is the size of the area represents the actual number of cell phone subscriptions. In this case, for example, in the United Kingdom or in Germany or whatever, and it is also it's grouping the countries together so that the big square left top represents Eastern Europe, and within that are the countries that belong there. I wasn't aware that the UK is in Northern Europe. Is that common to do it that way? Never heard of it. So, but you get the picture from the big to the small, so that all of it is representing Europe, and the parts of it like Western, Eastern Europe, and within that the countries, according to the number of subscriptions. Right, next up, waterfalls. Waterfalls is something very pretty, and also that shows how the community works, because when I compiled this talk, I found the waterfalls package with an S at the end, and I played around with it, and it didn't work very well, and then I found the other one. So I have an example, a very small example for a waterfall, represent waterfall visualization, some stock figures, like you have an inventory of 100, then you have to scrap something, you have purchased 150 items, and so on. And the waterfall shows the development in time in a very special way. So when I did that first, it would give me a graph like this. And it has a huge wide area here at the bottom, which shouldn't be there. So I thought there's probably some, I looked through my data if I did something wrong, but then I thought something is wrong in the package. I found out who made it. It was a guy called Huge Parsonage, and I found he was on Twitter. So I tweeted at him and then sent him that example and said, I think something's wrong. Can you take a look at it maybe? And that was sometime in January. By the end of January, there was a new version on CRAN. And after I installed that new version, this is what the waterfall graphic gives me. So there's a small margin here. Yeah, that's there for a purpose, but the big white area that was there in error is gone. So yeah, he corrected his package and pushed it to the CRAN mirror, and I could go, it was in February, to do this presentation for the first time with a proper waterfall graphic. Okay? So yeah, well, the waterfall is nothing special. You start with your initial value, and then you can see how it develops through time, and taking some away and adding some on top, and so on and so on. And at the end, the final value is calculated automatically, which is the total at the end of your time. And while I was waiting for an answer, I used this other package, the waterfall without an S, that by default gives me something like that. I found that not so compelling as the other one, so I'll stick to the one with the S at the end. Okay. I have no idea. How much time do I have left? Huh?
10 minutes.
Okay. We'll keep some of that brief, I guess. Okay. So let's get back to the car example. Correlation. Every one of you knows what correlation is. So I took the car example again, which has lots of numerical values, and I used the core function, which is base R, to generate a correlation matrix, right? That's what you see down here. And whatever, let me see, the MPG, let me see what have you, has the gears and the mileage has a positive correlation. So in principle it says if you got more gears in your car, you can do better on the mileage, right? Or Let me see, horsepowers and mileage, they're the minus, so in principle it says the more horsepowers you have, the more fuel you'll be using, because, you know. So, and each of these measures has a correlation to the other, and there are packages, of course, to visualize that. So that was, let me see, that's the ggplot edition, which by default gives you this one. And that's one of the few examples where the non-ggplot version, to my eye, looks better. Just in the default without giving it any special options. And also with that you can play around even more. Let me see, do it like that. Or I give it this one. You can print the correlation coefficients. I'll zoom into the next one in a moment. Nah, go away. What is it with this keyboard here? Stop it. Stop. I need that one. So here in this example you got everything it's got. Let me see where we have it. We have the positive correlation in blue, the negative correlation in red. We have where it's positive, the slope is from left bottom to right up, and where it's negative, it's the other way around, it's like that. Also, we have printed the coefficients in every field, plus where it's near to 1, it's a small line like this, and where it's near to 0, it's almost a circle. So that's all a combination you could throw in here of a correlation matrix. Okay, so what have we? Marginal plots. Okay, I have a plot of random data. Of course, I set a seed to make it look exactly the same every time I do this. But other than that, it's a normal distribution on the x-axis and a unified distribution on the y-axis. So if you just look at this, maybe some of you can tell where the median is, or where it's the real hotspot of the data is. I can't, so that's why you can add some marginals to it, either like this. So you can see on the y-axis there's a maximum here, so that would be the area where the most points are. And you see on the y-axis, I wouldn't have seen that it has 2 maximums of the point density. There are marginal plots for every taste, so you can have also a histogram. And forgive me if I run through this a little bit. You can even have a box plot on top of it, on both sides. Okay? Okay. So what have we still? We are in the car data set. I chose 5 of the cars and some of the measures, and here I normalized them to be the maximum at 1 and the lowest value gets a 0. So regarding not the absolute values, I don't care if the Lotus has 200 or 400, whatever. Let's put it there. The Maserati has 200 or 400 horsepower, never mind. It's the biggest one, it gets the 1. The smallest gets the 0, and the others in between. And with that, I can do what I always found to be a very pretty visualization, a radar chart like this. So you have the cars represented by the different colors. We have some axes in here that represent the measures, and so you can compare whatever horsepower. The green one, which is the Maserati, has the most horsepower. Then comes the yellow one, which would be a Ford Pantera. Don't know what that is, and so on. So you can watch it on every axis who is top and who is flop. Okay. Maps. Who uses maps within R? Oh, yeah, okay. A quick example of that. We have the German town of Kleve. They have a couple of public parking lots or parking garages, and they publish the number of places that are free at any given time. You can pull that over the internet. Let me see, and then I pull a map from Google Maps and combine those two in a minute, like this. Okay, it's a small town. That's the data from just now, 1426. I just pulled it live from the internet, and there you can see where the public parking lots are situated. Those are the colored circles, and you see where it's green, it's open. There's a red one that's closed, and there's even a blue one. It has some sort of distortion. I don't know if it's a distortion in the data or if it's a distortion in the parking lot itself. And you can tell by the diameter of those circles where the most free places are. Yeah, they give the coordinates in their data sets, so you can just plot them as points on the map because it has the same coordinates. Okay, almost done. Yeah, okay, I'll leave the animated things out because the GG Animate package just changed and they've broken it, so to speak. Who was it? Were you involved?
Oh, no, it's Thomas. Thomas Lynn Peterson, write him an angry email.
It didn't work, nothing worked. I mean, I don't have, forget it. So, something funny. And then we're almost done. Channel faces. Who knows channel faces? Yeah, of course. Oh, yeah, sure. I mean, still staying with the card data. One more dimension to put into this. You've seen this before. It has the displacement and the mileage. Again, mileage, the higher the better. And you can tell by the smiling faces here. That's nice to have higher mileage, and when you come down here, it goes like, I need too much petrol with this one. Okay? So it even has a scale here from up to 30 and so on. Yeah, I found it funny. It's not for every occasion, okay? Okay, I still have, I have one useful thing. And then I guess I'm about through. Let me just clean that one up here. I have the mileage. Yeah, that's nothing new by now, the mileage over the displacement. And then you can do something that's called facet zoom. Check out. Which does, no, come on. Which does this. That's the complete picture you had of the mileage over displacement. And they could say something like, I'm interested in these 6-cylinder models. And that pulls you that range out here to be on the complete width of your screen. That works also on the y-axis, and if I'm not mistaken, you can even have it at both axes at the same time, I think. So, okay, you need a big screen for that to work, of course, but it's possible. Okay? And that was nothing more than just this line up here. Add it to the plot. I don't know if you can see it. Facet zoom and give me the cylinder where the 6 cylinders are. Nothing more to it. Of course, you have to have the right package installed, yeah. Okay, yeah, I'll spare you the themes and fonts you can all use just to the short one at the end. Something interactive. Do it. Why don't you do it? Because it's there, of course. Okay, again, the same plot. I'm not going to bore you any longer, but this one has a nice feature. You can move your mouse onto one of these spots and it tells you which model it actually is. Volkswagen here, Nissan there, and so on. And I think you can even, if you use another nuance of it, you can even have it, if you click on it, it opens some website or fires some other action. I didn't dig into that, but it's possible. Okay, yeah, with that, I'm through. Let me get back to this one. Okay. So they're all listed up here. I'll post you the script as well. We have seen all of this. Whoopee. Okay, so, I mean, if you didn't know before, of course, you are the R guys, I'm the SQL guy. So a lot of is possible in terms of visualizations, of course, with R and the ggplot family and its extensions. And it always works in a very concise manner. Most of that, what I showed you, is just an additional command to a ggplot call. Okay, so with very little effort of source code. Yeah, don't overload it. Of course, if you have it cluttered like the first Formula 1 thing, it's no good. So you have to think how much of it you want to show. Yeah, colors and shapes are always, and yeah, channel faces not for every audience. Take that with you, please. Don't say, yeah, the guy showed it. Not me. I want to destroy the evidence. Right. Okay, some credits and resources. I was very much inspired by the top 50 of the ggplot visualizations and also some others. You probably know those books and the guys who wrote them. That's where my data came from. And then I'm at this point, time for Q&A. Are there Qs? I'll try to find some A's. Thank you. I'm going to post you the slides and scripts, and I'll have a GitHub where they will be available there.
Sure. I think that will be very helpful for people. So maybe someone has a question before we go into the break? No? Too many? You've shown everything, I think. Pretty complete statement of ggplot. All right. Thanks a lot then, Thomas.
You're welcome. Thank you.
SatRday.